Good morning, everybody. My name is Marcea Ascencio, and I'm here to tell you about my career here at Edwards Air Force Base as an electrical engineer. Throughout my presentation, if you have any questions, please feel free to use the text-in number 707-412-8922 to text in your questions, and I'll be happy to answer them at the end of my presentation. Let me get started here. I wanted to tell you a little bit about myself. I grew up here in the Antelope Valley, so I'm nearby Edwards, and I've seen these aircraft flying over my head ever since I was a small child. I had no idea, though, that I would be an electrical engineer out here one day with the 412 test wing. Fun fact, I think the F-22 is my absolute favorite airplane. And just a little bit about myself, I enjoy traveling, spending time outdoors, whether it's with my dog or snow activities, and doing a lot of volunteer work here around the valley. Let me tell you a little bit about my school. I went to 3 different schools to become an electrical engineer. So when I graduated high school, I actually had no idea what I wanted to study. I didn't really even know what an engineer was. I just knew that I really liked the challenge of STEM. And so I chose going to Antelope Valley College, which is down in Lancaster. And while I was there, I changed my major 3 times. So like I said, I started as a math major. I thought math was challenging, it was hard. I didn't always get it, and I really appreciated the challenge it presented. Finally, I transitioned into mechanical engineering. I thought that this would provide a good opportunity for me in the future. And then I took a circuit analysis class, and I fell in love with it, and I finalized my plans to be an electrical engineer. And there was no looking back and no regrets with that choice. My plan, of course, was to get in, get my classes done, be out in 2 years, and transfer to UCLA. And of course, things never go according to plan. And my actual was that I earned 3 associate's degrees with honors. I was a member of the Honor Society at Alpha Gamma Sigma. I had this really cool opportunity to become an intern with NASA JPL. I actually spent 3 years at Antelope Valley College, and I transferred to Cal State Long Beach. So as you can see, nothing went according to my plan, but I wouldn't change it, and I loved every minute of it. Once I transitioned to Cal State Long Beach, I was in the small Antelope Valley Engineering program. So that's a satellite campus based out here in Lancaster. And it's cohort-based, and it offers 2 disciplines of research, mechanical and electrical engineering. They don't only just focus on the curriculum, but they also push for students to pursue internships with the local aerospace industry. And that was something that was very appealing to me in my undergraduate career. So I studied all different types of electrical engineering. Electrical engineering isn't just circuitry, it isn't just electricity, there's a lot more to it. Power systems, communication systems like AM, FM radio, or maybe how the satellites are communicating with our ground-based equipment. There's also control systems of electrical systems, signal processing, you name it. There's a whole bunch of things that electrical engineers do. So one of the cool things I got to do while working with Cal State Long Beach was partner up with NASA Armstrong, that's based out here at Edwards Air Force Base, to work with an octocopter. And we fitted a secondary visual navigation system onto the airplane so that it can provide clear navigation position information for the airplane. So I thought that was a really neat project. While I was at Cal State Long Beach, I also started my career here at the 412 Test Wing as a Pathways co-op. And finally, I earned my BS in electrical engineering. After working here for about 4 years, I actually went back and got my master's degree just recently at the Naval Postgraduate School. The nice thing about this was that it was a 100% work-funded program. So I was able to take the time off of work, move to Monterey, California, and study. And as an electrical engineering student, I was able to specialize in guidance, navigation, and identification, as well as cyber systems. I also was able to do some thesis research with autonomy, machine learning applications for navigation. The nice thing about Naval Postgraduate School in electrical engineering was that I was able to take these engineering concepts and apply them to how the military would use them. And I thought this was a neat opportunity. And to my surprise, my master's degree was actually much easier than my bachelor's degree, which seemed a little counterintuitive to me, but I really enjoyed it. And by the end of it, I earned my Master of Science in Electrical Engineering, so I'm through and through a double E. So what is electrical engineering here at Edwards Air Force Base? The options are absolutely endless, and I'm going to cover just a few of them today. So some of the examples include special instrumentation. So there's a team of engineers and technicians out here that do all of the work to fit our aircraft and our test systems with these special instruments to collect the data, transmit the data, and record the data. Everything we do out here for our decisions is based around this data. And so more often than not, if you see orange equipment and orange wires on these airplanes or these test systems, that is special instrumentation. And as a discipline engineer like myself, I use this special instrumentation every single day. And so there are engineers who design these systems and integrate these systems onto the aircraft. Another group that has electrical engineers is the electronic warfare group. These engineers here leverage the electromagnetic spectrum, and they are able to use it for offensive and defensive type testing and analysis. So I've included a picture here of our anechoic chamber. It's a very neat facility that our EW engineers utilize quite a bit to test aircraft systems without the signals escaping the building. And finally, I've included the avionics and mission systems types engineers. So this is where I fall. And this includes a whole array of different types of disciplines that you can learn. So there's guidance, navigation, and identification. How do aircraft navigate and identify themselves? We have communications between different systems. We have radar, electro-optics, weapons integration, which I think is always a fun thing to experience, and mission planning. So there's a whole array of options here as an electrical engineer. And the nice thing is that you're not just restricted to this type of work. So with electrical engineering, you can actually go and learn some of the other types of engineering like flight sciences and aerospace and do cross-disciplinary work. And I think everybody here is really good at mentoring and training everybody so that they can do the job and have that experience and expand on their technical breadth. So I work at an Air Force base. Where are the airplanes, right? And so I've included this cool video. Oh, we'll see if we can get it to play for you here, of some of the airplanes I've gotten to work on. So these are F-16s and F-35s. I think that this is some of the fun parts of my career, is getting to ask the pilots to do these cool maneuvers. And we have experts flying these airplanes and can do all of these fancy tricks safely and collect the data that we need. So what does my day at work look like? Like I mentioned, I specialize in communication, navigation, and identification. More specifically, I'm responsible for planning the tests. So I get to decide, how are we going to test this navigation system? How are we going to know that the aircraft can receive the GPS signal and utilize it the way that it's meant to be? I'm also responsible for provisioning and gathering things for my test. I think execution is definitely one of the best parts, where I get to go and support these test missions that we do, whether that's airborne and I'm sitting in a control room working with a team to tell the pilot what to do and what information we need, or I'm sitting on the ground myself inside the airplane getting to run the test. My next favorite thing is, of course, the analysis. This is where we get that data from all of our instrumentation, and I get to assess the system. And finally, one of the most important things I get to do is create the reports. And so the reports that we write as engineers here support the Air Force's decision and other stakeholders' decisions to move forward with adapting this technology for the warfighter. I'm ultimately responsible for answering questions like, does it work? What doesn't work about it? Even if it works, does it provide utility for the warfighter? And I think this is an awesome job. And the best part about it is that new projects come every single day. And I am never working on the same thing. And I love having a new challenge. And each and every day here, the test wing is moving forward, bringing in new projects and providing new challenges for our engineers to solve. So let me start at the beginning. I started my career out here working on the F-16s, and I was a Pathways co-op, which means I was here part-time while I was in my undergraduate school. And the nice thing about this was that I wasn't treated as your run-of-the-mill intern. They gave me real responsibilities as an engineer. And that included things like working tactical air navigation, working on embedded GPS jammers on the aircraft. But I think one of the most interesting programs that I had the chance to work for was the European Participating Air Force F-16 Testing. And this was a collection of European countries that owned F-16s and required testing of their aircraft. So I actually had the opportunity to fly out to the Netherlands for 2 weeks and support testing of Dutch F-16s. And I thought that was a really cool opportunity and a lot of responsibility for a co-op. And it was a great opportunity to learn more about how we did flight test here and provide that for the United States Air Force. So once I transitioned out of the F-16s, I went to the F-35. And I was really excited for this because we were testing the mission systems or the avionics on the F-35 for the Air Force, Navy, and Marine Corps. Of course, it was a lot of excitement because this is our newest 5th-gen fighter that we're testing out here. And I also specialized in communication, navigation, and identification systems on here on the F-35. I was able to go in and work important milestones. If you look at the bottom right picture, that's me inside the cockpit in the middle of the night running a ground test. I think that was probably one of the highlights as an engineer, being able to just sit inside the airplane and run a test. Of course, we don't get to fly the airplanes, but I think it's great. And I think some of the most important work that we did while I was at F-35 was adapting this auto-ground collision avoidance system onto the airplane. So I'm going to go into what is AutoGcast. This video gives you a demo of some of the testing we did, where we actually had the aircraft diving at the ground and had the system recover the aircraft automatically. So the pilot provided no input to recover the aircraft. And so this is really fun to plan. It's also really fun to execute. It's a little scary too, because it's not a natural feeling to want to dive at the ground. So what is AutoGcast? AutoGcast, like I said, is a system that will determine when the aircraft is going to hit the ground or hit a mountain and automatically recover the aircraft without pilot input. Now, this is life-saving technology, and they've already put this onto the F-16, and it's already saved, I believe, around 8 lives. So we put that onto the F-35, and we moved it forward as much as we could. Some of my responsibilities, specifically for the F-35 AutoGcast program, was to test the trajectory, test that the map generation was right so it knew exactly what the ground looked like, and then, of course, put that all together and provide a model for the system to actually evade the ground. And so since we did such a good job moving that forward 7 years to get it onto the aircraft, the whole entire team actually won the Collier Trophy. And I had the opportunity to travel to Washington, D.C. for the ceremony. Now, the trophy isn't ours per se, but it does reside in the Smithsonian there in Washington, D.C. So next time you're at the Smithsonian, check it out. F-16, F-35 AutoGcast team was the recipient. And I thought that was a great opportunity, but more so a great opportunity to provide this critical technology for our warfighters. So where am I at now? Right now, I'm working at the 411th Flight Test Squadron testing my favorite aircraft, the F-22. I also am serving as the CNI and Tactical Data Links Engineering Lead. So I have a team of about half a dozen engineers that we get to walk through the modernization efforts that are ongoing at the F-22. The really cool thing, I think, is that my job is not just about modernization of the F-22, but also supporting this world's most air-dominant fighter. And although I'm relatively new to this position, I'm really excited to be testing my third and favorite fighter. So where do I see the future of the 412 test wing? Engineers are, in no surprise, in great demand. And we have new technology coming in here every single day. We have new aircraft that need to be tested. So I've included a picture of what the next generation air defense looks like. We have new bombers. We have new cargo aircraft. We have a lot of things coming down the line that need new engineers and new brains. A lot of our upcoming testing will also emphasize things in the cyber domain. So how do we address the threat of cyber attack? How do we look at the internal architecture of these systems and determine where we need to improve or where we need to test? A lot of new work is also including autonomy. And so how do we test autonomous systems? Now, I think we also require a lot of new engineers because diversity allows us to test more efficiently when we can gather a bunch of different inputs from people of different backgrounds. We're also looking to advance our analysis techniques and create better modeling and simulation so that we can use that information before we actually go and flight test the aircraft. So what can you do if you're thinking about becoming an electrical engineer here? I would encourage you to take STEM classes in school, whether that's in middle school or high school or even college. That can include a variety of things like mathematics, physics, biology, chemistry, and get a feel for it. Now, don't be too hard on yourselves. These classes are going to be a challenge, and you're not always going to get that A+ on every single assignment that you do. But that doesn't mean you should give up. These classes will teach you a lot about the material, but it'll also teach you a lot about yourself. I also encourage you to join STEM clubs. So I didn't join STEM clubs until I was at Antelope Valley College, which is a long time away. And you'll get to meet other like-minded individuals. You get to do fun projects, take really cool trips or adventures out to do STEM-related things around your community. Another thing I encourage is to participate in local STEM events. So I know that there's the Science Olympiad event that's hosted annually. I'm not sure if it's still going on right now, but I used to be a judge for some of the middle school events, and I always thought it was a good opportunity for students to learn more about STEM and actually apply it in their events. There's also things like mathletes and robotics clubs, and I would encourage you to seek those out. There are also local engineering societies. So I guarantee you that if you plug any one of these 5 societies into Google, you will be able to find a lot of information. So I listed just a few here that I've participated in. The American Institute of Aeronautics and Astronautics, or AIAA, is great. And we have a local chapter that's very active, does very cool presentations and networking events. Women in Aviation is another one I'd like to highlight. That I've been a part of. And if you're remotely interested in working in aviation or becoming a pilot or working on the ground with airplanes, you should check out Women in Aviation because they offer scholarships for a bunch of different people, female and male. Please take a look at these. I think they're great. You can find a lot of information. And once you get into college, I would encourage you to pursue internships. So a lot of different companies, and our Edwards included, has internships that they offer for college students. And these allow you to get that hands-on practical experience that is going to make a difference in your career. So that's all I have for you today. Please, like I mentioned, text in your questions, and we'll be happy to answer them.
All right, ma'am. We do have a bunch of questions saved up. A 5th grade class in Palmdale is wondering, before college, what schools did you go to?
So I grew up in the Antelope Valley, and that means I went to Rancho Vista Elementary School, Hillview Middle School, and Quartz Hill High School.
What were some of your favorite and least favorite parts of school in general?
I am very motivated by being challenged, and I think that it was frustrating when I would take an exam and maybe not do my best, and that really motivated me to do better. So I think my least favorite parts was just that struggle, right? But the struggle taught me to become more disciplined and to learn different techniques to do better next time. Of course, I'm very extroverted. I love working together with teams, and so that includes group projects and being able to present in front of the class. That was probably some of my favorite parts in my K through 12 education.
All right, thank you. What are some of your favorite and least favorite parts about your job?
Well, I think hands down my favorite part is just driving onto the base and seeing these amazing aircraft flying. It's like an air show every single day. And like my colleague mentioned earlier this week, just being able to walk outside the office and go and touch that F-22, right, and do testing on it is phenomenal. I think that reminded every single day of the mission we have here with the 412 Test Wing to support the Air Force and testing for the Air Force. And I think that inspires me every day to do the best that I can. Some of my least favorite parts maybe is a lot of the paperwork. So we want to make sure that we have everything in line for our testing and our safety and our reporting. And although I love technical writing, sometimes you can hit a little bit of a writer's block. And you really just want to go out and do the fun things like playing with the airplane. But that's just part of the job. And even when I do that, I'm still happy to work out here.
Speaking about testing, what was the favorite test that you've done?
I think some of the favorite testing I've done was actually the in-country developmental testing we did on the Dutch F-16s. So I had the opportunity to fly out to the Netherlands for 2 weeks, and we were able to brief foreign military pilots on the testing we needed. And though we didn't have the type of situational awareness on the ground like we do here at Edwards during the test, I thought it was a really important mission, and it was really interesting to see how we could adapt the Air Force testing into the military styles of the Dutch government. I think that was probably some of the most memorable testing I've done.
On average, about how many tests do you run per day or per week?
So it really depends on what phase we're in. If you recall, I talked about those 5 phases that I'm responsible for: the planning, provisioning, execution, analysis, and reporting. So during execution, you could be running tests about 2 to 3 times a week. And our missions are several hours long with the fighter aircraft. We don't get to fly quite as long as some of the bigger aircraft that can carry more fuel. But during the other phases, we may not be flying so much. Like right now at the F-22, my program is not executing quite as often. And so I might be testing once or twice a month versus once or twice a week. It really just depends.
Got a really good question. What happens if a test fails, and how is a fail defined?
So more often than not, that is what we find, is that systems will fail or maybe not reach the specification that we want it to. And that's okay. You have to learn how not to take it personally out here. Our job is to test this system the best that we can and make sure that it is adequate for the warfighter. And when we test these, sometimes the systems don't match up to what we expect. And the best thing we can do is be very objective about it and be very clear and say, we did this test and we had this result, and therefore we do not believe it meets the requirement. And you just have to be very technical about it, not emotional. And of course, we want to see everything succeed. So when it does fail, we want to make sure that we capture all the required data and we communicate to all the designers and the other individuals who contribute to the success of the system so that they can go and fix it.
So one question that they had was, how do you test ideas before you test in flight?
I'm sorry, can you repeat the question?
How do you test ideas and systems before you test them in flight to make sure that they're safe to fly?
Okay, so I'll give you an example with our automatic ground collision avoidance system. So that required a lot of diving at the ground, right? And that does not sound safe because you don't want to rely on a system that's being tested to actually recover you above the ground. And so we leveraged a lot of the simulators that were offered for the F-35. And we sat in a room with a bunch of technical experts. We developed these ideas together based off of what we'd known with previous testing on the F-16 and previous flying qualities testing on the F-35. And we developed a plan. And then we went to the simulators and we were able to actually practice these plans. And this allowed us to gain reassurance in that we were doing the right thing and we were not putting the aircraft in harm's way. We also get to use algorithms and different types of math to calculate aircraft trajectory and worst case scenarios. And we leverage this kind of information in our test ideas as well so that we can make sure we're doing the test efficiently and we're also making it very safe for the aircrew.
Have you ever gotten to ride in one of the airplanes while you're testing on it?
I have not had the opportunity, although I know a lot of my colleagues have had the opportunity to fly in these aircraft. I'm a little bit limited because on the fighter aircraft, only the F-16 has 2 seats. And so the F-35 and F-22 do not have a backseater, and therefore we don't have engineers flying on them. However, some of my colleagues who work on some of the cargo aircraft or the aerial refueling tankers get to fly on board the aircraft with the aircrew and evaluate the system. So I think there's a lot of opportunities out here if you're interested in flying. There's quite a few jobs out here where you get to fly on board the aircraft to evaluate the system.
What are some of the most difficult challenges of electrical engineering on aircraft?
So with electrical systems, I feel like they kind of have a mind of their own sometimes. You would think electricity is pretty straightforward, but when you jam a bunch of different electrical systems into a very tiny space, like on an F-16, it's a very small aircraft. If you've ever gone up to one, that entire aircraft is filled to like the centimeter level almost with these systems. And they actually will interface with each other sometimes. And so we may be testing an antenna on board the aircraft, and it may not be working, or there may be something called interference on it. And we have to figure out exactly what's causing that interference so that we can make sure to design our tests in a way where we don't have that. So that's one thing that we deal with quite a bit. Also, just understanding all of the information. The F-35 is a powerhouse for data, and there's a lot of different communications going across the systems. And as an electrical engineer, it's my job to go in there and make sure that all the beeps and squeaks are acting in accordance to specification. And sometimes that can be a challenge when you have a mountain of data to look through.
So that kind of ties into this question. Might be kind of a big ask, but about how many different electrical systems are in a single aircraft?
Oh, it's hard to quantify. I can tell you that there are thousands and thousands of communications going on in each and every single one of them, and I can't even really quantify how much it is in a bigger aircraft like a C-17 or a KC-46. I'm responsible for the electrical systems that have to do with navigation. So this includes things like the inertial navigation and the GPS and some of the radios that the aircraft uses to communicate with other aircraft and ground-based assets. So think about it, it's thousands of things to look at, and it's a lot to learn. Every time you start on a new aircraft, there's a lot to learn. You'll meet engineers who have been working on it for decades, and even they don't have 100% of the aircraft figured out, although they're pretty close.
So going back towards how to test ideas safely, has anyone been hurt or injured in our tests?
Thankfully, nobody's been injured while I've been here, although flight test has a history of being dangerous. And so that's why I think the Air Force is very focused on being as safe as we can and implementing safety guidelines that just make sense so we can still get our testing done.
If memory serves, I think the last aircraft we had go down was in '08. It was a Raptor, unfortunately. You mentioned before that you like to travel. What was your favorite place to visit?
Oh, I actually had the opportunity to go to Europe back in 2019 in the summertime. And I had the opportunity to go to England to work with the Royal Air Force and talk about their upcoming integration of automated collision avoidance technology for airborne considerations with the F-35. I thought that was a great opportunity. And I also got to take a little bit of personal time outside of work to travel through the United Kingdom. And I think that was probably one of the coolest travel adventures that I've had.
One person asked, do you see yourself changing jobs in the future?
I don't think I will change what I do out here. I really enjoy working as a flight test engineer, specifically for navigation systems. Now, I think one thing I've appreciated with my job with the 412 Test Wing is that they will often cycle us through different aircraft. And I think that presents a whole new array of challenges and problems to be solved. And I think that's what keeps it fresh and keeps me coming to work every single day. So I know that in the next 5 to 10 years, I may not be working on the F-22 for that entire time. I'll be able to work other aircraft and to work other programs. So right now, I'm really happy with the work that I get to do and being able to apply my knowledge of navigation and identification testing on these aircraft. I don't think that there's a limit to what you can do here. I really do believe that you can do just about anything out here at Edwards Air Force Base, and I'm excited to continue my career here.
One person asked, about how long did you spend in college, all told?
Ooh, altogether, I spent 5.5 years. So like I mentioned, I wanted to get into Antelope Valley College, get my classes in, and get out in 2 years. And it ended up taking me 3 years, which is fine because I was able to knock out all my general education classes and a few of my engineering classes. So once I transferred, I did 2.5 years with Cal State Long Beach. So 5.5 years just to get my bachelor's degree. For engineering, that can really range. Some people will get it in 4 years, some people will get it in 6 years. It doesn't matter how long it takes you, just keep going. Now, adding in my master's degree, that was 1.5 years. So that was 7 years altogether. And it sounds like a lot, but believe me, it goes very fast. And the nice thing was that I was able to work for a few years here at Edwards Air Force Base before going back to get my master's degree. So having that reprieve from school and schoolwork and the school mindset was very nice. And the 1.5 years flew by with my master's degree.
So one thing that we hear a lot about lately is innovation. What are some of the skills needed to innovate, and how can we develop those skills in ourselves and teach them to other people?
Innovation is very, very important out here at Edwards Air Force Base. And I think that some of the skills you use to innovate better is to really just have that passion about what you do, and make sure that you're always leaning forward and asking yourself, how can we do this better? And sometimes we'll find ourselves out here doing processes that we've been doing for decades, and maybe it doesn't make sense anymore. And so we need individuals, whether you're an engineer or not, to ask the question and say, do we really need to do this? And what's the reason behind this? And I think that maybe not so much a skill, but just a mindset of having that forward-leaning ideas. I think also it's important that we include individuals from diverse backgrounds. When you have more diversity in the workplace, you are bound to have different ideas. I don't think engineering is black and white. It's really an array of colors. And I think that individuals will bring different ideas to the table, and that allows us to move forward successfully and innovate new ways to do better testing out here.
One person asked, what did you want to be as a kid?
Wow, yeah, that's a hard question, because if you asked me in elementary school, middle school, high school, I probably could give you a different answer every single time. At first, I thought I wanted to work in the medical field, and then I realized I was not cut out for that. And then I thought I wanted to work in accounting because I kind of liked math and it sounded like a good idea. And then I realized I didn't want to do that. So I had a whole array of ideas, but it wasn't really until I was about a year into my education at Antelope Valley College that I solidified the idea of becoming an engineer. If you had asked me in high school, I wouldn't have even been able to tell you what an engineer does. And now I couldn't think of a better career for me.
So speaking of college, what are some of the important things to remember as you're going through college?
So as you're going through college, it's really important to work on those academics, but it's also important to foster some of those soft skills. So you're bound to work in groups together. You're going to be assigned projects that are really hard. And it's important to be able to have that time to problem solve with your team and create efficient communication. So I think out here, there are no engineers who are just working by themselves all the time and solely responsible for, an entire airplane. We work in teams out here. And I have to work with a lot of different types of engineers. And I think that while you're going through college, it's very important to learn how to communicate with others and be able to identify problems that need to be solved. And you can do this in college by joining some of those clubs and extracurricular events. And just networking and being able to interface with other individuals will teach you a lot about yourself and how you can apply these engineering applications into the real world.
Looking back, are there any decisions that you made in college that helped you along your career, or any decisions that had a bigger impact than you expected them to?
Yes, absolutely. So I look back and think about this all the time. Should I have done the 2-year plan and transferred to UCLA, or should I have joined this club or not joined this club? And I think some of the pivotal moments I experienced were actually at Antelope Valley College. And once I joined some of the STEM clubs out there and joined the Honor Society, I was surrounded by a community of hardworking individuals. And I think we are who we surround ourselves with. And when you surround yourself with friends who encourage you, and coworkers and colleagues who encourage you and expect you to do your best and support you when you fail so that you can get up and do better next time, that's very important. I would also recommend that you find mentors. So whether or not you're in college and you're in K through 12, find somebody that you can rely on for advice, whether that be a teacher or a parent or a family member or a friend, somebody who can give you good advice about what to do if you want to become an engineer or maybe a different STEM career. They will be able to help you. And I think I had mentors along the way, many of them, who were very encouraging and believed in me when I didn't always believe in myself. I think that is critical for you to make it through. Engineering school is not always the easiest. And when you have people supporting you along the way, it makes a huge difference.
What are some of the innovations or technologies that you would like to see either applied to the Air Force aircraft in general or as a larger part of the industry?
Well, I think that this has definitely been shaped by my work on the F-35. I would really like to see more autonomous technology integrated on this aircraft. Of course, we have some of the top-notch pilots out here at Edwards Air Force Base. Test pilots are phenomenal at what they do, and the Air Force has an array of very, very capable air crew across the entire Air Force. And so I think there are still some mistakes that pilot makes that can be either risky for the aircraft, unsafe, or maybe just not as efficient. And so with automatic ground collision avoidance, that system has already proven itself on the F-16 to save lives and to save aircraft. And so I think I've been very passionate about seeing that technology through on the F-35, and I really hope to see that technology continue on different types of aircraft. And this is not just military aircraft, but general aviation as well. I think that anytime we can help save a life is great, and this autonomy will help make sure that it's done without error. Autonomy can be used in the mission systems realm too to make more efficient targeting, more efficient information that the pilot doesn't have to do by themselves. So I think that as we go forward, I'd like to see more autonomy out here, and that will present a whole new array of challenges for testing and reporting for our engineers out here.
What are some of the skills that we would learn as young people in school besides curriculum stuff? Like, what are some of the skills we learn that would be helpful along the way?
So some of the most important things you can learn is how to work on a team, whether that's being a leader or standing back and allowing someone else to lead and making sure you support the vision. I think also problem solving is a huge one. I like to think of myself as a professional problem solver sometimes. We get handed a whole list of problems every single day, and we need to figure this out. And I don't mean math problems. I'm not getting handed math problems anymore, thankfully. And we get to solve them. And sometimes they're very complicated, and sometimes they require working with others. Oftentimes they require working with others, which leads me to my next point, communication. So I don't mean just getting up and talking in front of your class every single day, but learning how to communicate with others. Sometimes people are shy. Sometimes people aren't really good at conveying what they are thinking or what they want. And so being able to identify what kind of individual they are and how to communicate with them best is very important. So I think those three things are key to focus on: being on a team, being able to problem solve, and being able to communicate.
All right, and one last question. What would you say is the most surprising thing that you've learned on the job?
Wow. I think something that took me for surprise was just how great the collaboration is out here at Edwards Air Force Base. So when I was a student, before I got my internship at the F-16s, I did not believe in myself. I thought that I wasn't that top-notch engineering student. You know, yeah, maybe I got a B on my math test or my physics test, right? And I felt that in order to be an engineer here at the test center, I needed to be A+ every single time. And I thought that I wouldn't do well out here. And when I started at the F-16s, I quickly realized that it wasn't just about that detailed math test that I took. It was about being able to learn and to ask the right questions. One of the most insightful things my professor said to me in undergrad was that engineers don't always know the answers, but they know what questions to ask. And that has really guided my learning out here. And it took me for surprise that I was actually pretty good at asking those right questions and then finding the answers. But no, I don't know all the answers. And the team of engineers and technicians and aircrew and everybody who works out here at Edwards Air Force Base really come together to make sure that we get those right questions answered.
All right. Thank you, ma'am. I believe that's all we have time for today. Remember to come back this afternoon and tomorrow morning for more speakers. Thank you.